Welcome to week 5, project 2, DENT 1158. We just want to go over this prescription first with our second project of this semester. And you all have the model by now and received and made occlusion rims. This one is still a Kennedy Class 1. Unlike the other one though, this one will be a lingual apron, plating the 3-4, 3-3, 3-2, 3-1, 4-1, 4-2, and 4-3, and 4-4 above the height of contour. These are reciprocating plates. So the apron on 3-4 and 4-4 will act as a reciprocal bracing arm for the G-clasp on 3-4 and 4-4. Our finishing line straight down. And then our mesh retention finishing just distal, roughly, of the prosthetic 6. So while we're waiting for our project 1 to cast, we can go and block out, survey, tripod, and duplicate our second project. So this will be a lingual plate. Unlike the lingual bar for the first project what we did. Now the lingual plate usually is used if we need some more bracing of the anterior teeth. It increases indirect retention. More bracing if there's some mobility. Not a great reason, but it is one. And I think the larger one is anatomical. If there's no room lingual sulcus for a bar, then we can move to a lingual plate or apron. If the floor of the mouth is high, or lingual frenum high. We've got our G-clasp on 3-4, G-clasp on 4-4 in red. And this will be in our marking guides. And here you'll do major connector lingual apron. And then G-clasp 3-4 and 4-4, mesoocclusal rest on 3-4 and 4-4, and mesh retention in posterior, obviously in the posterior. But we're still anticipating on putting a full complement of prosthetic teeth at the back, depending on the opposing dentition. But the retention, for reasons we talked about, some of you missed it, will stop roughly around 6, which is generally the deepest part of the edentulous area. We don't want to get any mesh on an inclined plane. There's very limited room back there, especially someone that's bilaterally edentulous in the back, probably some over-eruption of the opposing dentition. And then if you can visualize, the flange attached and detached mucosa, just like our full dentures. You don't have to draw this, but it'll go on something like this. Just so you can visualize that this is just the framework or the substructure of the partial denture. Here's our prescription. You'll put this in your marking guides. Now, one thing we've talked about, or we will talk about if we haven't already, that in this Class 1 design, there's really, I'm just going to fast track, there's only 3 direct retainers that will be used for the bilateral free end. And the first one is the first case we did, an RPI. R standing for rest, P for proximal plate, and I for I-bar. The first one we did was the next one, RPG. Rest, proximal plate, G-clasp. And a third choice from the infrabulge clasp is the RPY clasp. These 3 are theoretically your only choices for Class 1 bilateral free end. The rest here in all 3 is always placed on the mesial, as such in my drawing. On the free end, we try to anticipate a rest on the mesial as much as possible, if not all the time. And what that does is it moves the fulcrum line further ahead. There is a rotation in the tooth tissue supported RPD. And there is a fulcrum line, and that is an imaginary line drawn through the 2 most distal rests. And around this line there is a lifting and a loading of the partial denture. I mean, this is one of the 3 rotations. We have some side to side, and we have the biggest one would be anterior posterior. So to counteract the occlusal load and the compression of the tissue at the back, we need to put something here. These 3 choices here of clasp design, these are stress breaking clasps. These are stress breaking clasps, meaning they will dislodge, or they're a lot more pleasing to the periodontal ligaments of these abutment teeth. Keep in mind now, we've lost antagonistic teeth on the marginal ridge here of 3-5 and 4-5. And when that happens, we'll have some bone loss occurring on the distal guide surfaces of 3-4 and 4-4. And with that bone loss, these teeth are subsequently a lot weaker than the rest. We need to put as less pressure on these as possible, especially in the free end situation, when the load is applied here from the occlusal load, that there's a rotation that wants to happen around this line, this fulcrum line. So we've moved the line further up with meso-occlusal rests. Okay, semantically there's a plate. We can discuss that later. But we've moved the fulcrum line up further, and the mesial buccal arm of 3-4 and 4-4 will engage the undercut when the load is applied in the posterior section. Now we have no anchorage in the posterior section, and when a lift has occurred, meaning these free ends tendency have, this is all minor, minute movements. When this free end has a lift, then this whole plate in situation will be something we will call the indirect retention. So this is an indirect retainer. In this case, it's the whole plate. Technically speaking, if we bisect the fulcrum line halfway point at 90 degrees, then this would be the most optimum counteracting the lifting force of an indirect retainer, is these 2 centrals on both sides. We know that centrals and laterals, crown to root ratio is a little less. So I think favorable indirect retainers in this situation would be 3-3 and 4-3. Now in this situation, it doesn't matter. We've plated all 8 teeth. So we've got that much indirect retention counteracting the lift. Now, in diagnosis of how much lift or load we're going to have, there's some factors. The length of the free end, the height of the free end, meaning the occlusal height, vertical dimension, the length, and the ridge height. Is our ridge height rounded, medium, or flat ridge? And the flatter the ridge, the more rotations you're going to have left and right, and anterior, posterior, and even circularly around these abutment teeth. Now that was a mouthful all in about 5 minutes of the biomechanics of cast partial denture design Kennedy Class 1. But the takeaway points here are that all Kennedy Class 1 designs, upper or lower, should have a meso-occlusal rest on the distal abutments. The teeth adjacent to the free end are always the abutment teeth and should be categorized as the abutment teeth to begin with. If they're questionable, then restoration or extractions has to occur before the design. So, takeaway points again, meso-occlusal rest on the terminal abutments. The terminal abutments are those adjacent to the edentulous area. An indirect retainer must be utilized in a Class 1. You must have one, something to counteract the lifting force of the free end. What is an indirect retainer? Bisect the fulcrum line. Medially at 90 degrees is your most optimum indirect retainer. If it's in the anterior section, then we'll favor 3-3 and 4-3, something with larger anchorage teeth here, or more crown to root ratio. That'll prevent any kind of labial drifting from lifting of this posterior ridge. So when we're treatment planning, we're looking at the length of the occlusal table or the length of the flange, most likely the occlusal table first, the vertical dimension of the occlusal table, the height of the ridge, and the amount of undercut on these terminal abutments. Another takeaway point, indirect retainer, meso-occlusal rest, and these 3 clasp choices are your academic 3 choices. Most people in the dental practice will say, well, make an embrasure clasp, engaging distal buccal of 3-4 and mesial occlusal of 3-3. I'll just try to draw it over here on top. And what happens with this is they'll say, well, great. Now when we got a load that the mesial labial clasp of 3-3 is engaged, and when we got a lift, then this will counteract the lift. But what happens is this type of clasping is so rigid that, yes, it's excellent for retention, but very poor for stress breaking. There's no stress breaking values of this clasp. Retention is definitely increased, but counteracting the tipping forces of a class 1 partial denture that goes back and forth, excellent. But bounding of these two natural teeth so rigidly, and then every occlusal load on the posterior will stress these abutment teeth, lift or load, and elongate those periodontal ligaments over and over and over again as this partial denture is inserted and taken out. So we have to refrain from using anything not stress breaking. So I've given you 3 choices of stress breaking clasps, and you'll find this in your manual for class 1 design, which is somewhat the most popular, or I should say most popular. It's the most complicated in biomechanics because there is this rotation in Kennedy class 1 and 2. Specifically 1 even more because both are free end. So these are our 3 clasp choices: direct retainers, RPI, RPG, and RPY. We know what these clasps are. The P is the proximal plate, and the R is the rest. And the rest is always on the mesial. Why? To shorten the fulcrum line, to move it more to the anterior, to reduce the amount of indirect retention. We're going to move this fulcrum line further, anterior. If we have 2 bicuspid, or I'll have my canine and my 4 here, if we were to dissect one free end, and we would put the rest on the distal, this is my free end, FE. This is from my drawing above. If we put the rest on the distal, the occlusal forces will come down, the patient will bite down, depending on the length of this occlusal table, will cause this abutment tooth to be pulled into the distal direction. So when we put the rest on the mesial occlusal rest and we push down, it will push it into the abutting 3-2-1. Therefore, we won't have any distal drift of this abutment tooth. So once again, mesial occlusal rest, forces of occlusion will create this type of direction of the abutment tooth microscopically. Microscopically, please. If we have a load and a distal occlusal rest, it'll pull the tooth into the free end, and we know these periodontal ligaments are already compromised. So we're going to go over this multitude of times, not just once. But I want to go over it briefly to kind of round up our second project here with class 1. So we're going to bring in the class 1 model here. And the first thing I'm going to do with my analyzing rod, this is a review now, is I want to check the undercuts on the guide plane, if not minimize them or equalize them or eliminate them completely. Now I've made this project very simple on this hand-created model, that this is pretty much straight up and down. If you want to keep this screw here kind of taut, but you can still move it, but it kind of holds the position, I think this will help you. So what happened is I've got it kind of stiff, but I can still kind of move it. Anterior, posterior. And then I'm going to turn it around for you to see here the height of contour on 3-4 and the height of contour on 4-4 is pretty much the same. The height of contour. I don't want one higher and one lower. I try to equalize this as best possible. So once I've, well, I should put that back in. Once I've created the path of insertion, I'm going to complete that by tightening the base, tightening the model to the base. Tripod, I want you to do both ways. I think it's a good habit to get into. In case something falls off the model on one, you'll always have it on the other. So X and Y axis with the analyzing rod, somewhere in the middle. Make sure it's a sharp pencil. I could use that advice right now. So as well, when I go to the carbon graphite, I will... carbon graphite, please. Typical. There we go. It was hiding. Now, the surveyor looks kind of like a complicated thing, but really we're not using it that long period of time. It looks like a complicated device. Maybe it would be if we were doing milling or designing some crowns or something, but really we're just paralleling the guide surfaces to the plane of to the path of insertion. Another tip here, try to keep some lead at least long as the abutment tooth, right? So I'm using two hands here. I'm moving this one with my right hand up and down, if I'm right-handed. And then I'm going to move the model with the base on the table here. I think Musa had suggested, someone put some polymer here so it slides kind of nice. And then you can mark the height of contours on the 3-4 all the way around, 4-4, all the way around. And everything below that height of contour on the reciprocating side at least will be blocked out. Oh my, a little bit loose, my lead here. Now, we talked about the purposes of surveying. We're also checking soft tissue undercuts. If we look at the height of contour of the soft tissue, that we would have to, if we used an I clasp or a Y clasp, there would be too much undercut below this here, because we know the I bar should have 3 to 5 millimeters. This would be really undercut and get a lot of cheek and food debris. Not cheek as a debris, but we get some cheek impingement and some food debris. Oh, I should have left that in there. And I'll get it back out. And tripod the model the second way. So order of operations here, I was a little cavalier in moving quickly, but I'm sure it's going to happen to us all. So 3 arbitrary points with the upper member in one place, widely spaced. So you can see the markings I've made. This is lead. This is all graphite markings. I want you to make an X with a sharp pencil. Hash mark this line in half. Bisect it medially and circle it. And here we have our 3 tripod points. College of Denturists will ask you to do this in one of their OSCE scenarios. That's the easiest thing to do, really. And if we don't practice it, then we'll feel very foreign to what our expectation is from them. So I'm going to put my analyzing rod back in. I'm going to bring my Blockout wax back into play. As you can see here. And maybe we missed this on the first one, but really I want, if there's no undercut on the guide plane, then I want you to block out at least the gingival margin on the guide plane. As you can see, I've put it on and taken it off, and very faintly there's a thin layer below. There really is no undercut, even though my lead line is higher, because I had a tapered piece of lead there that didn't go all the way down, but really there's almost nothing. 0. I'm going to get and block out all below the height of contour for my retentive arm. Now, I know many of you are thinking like, well, hang on a second. Did he measure the height of contour? Did he measure the depth of the undercut gauge? Well, I didn't. But just to show you that you'll create the same issue, I'll take the wax off at the terminal end of my G-clasp. I'm going to put in my 0.25 undercut gauge. I'm going to bring the 0.25 undercut gauge to the mesial third of my abutment tooth. Let's zoom in up here a little bit. And then I could, even if I just put a tiny, tiny little indentation in there. And then we said roughly a half is below the height of contour on the bicuspid, and the other half is above the height of contour. Without waxing the way on this side here, I'll bring it up until that undercut gauge touches the tooth. Sorry. And then half is below the height of contour. The mesial half is the retentive portion of the clasp. And it comes up here at the shoulder. And when I look facially, those two clasps are about the same height. Now I can continue at a feverish pace what I was at, and blocking out everything below the height of contour, and then cutting back my ledge to support my retentive arm. So therefore that ledge is replicated in the refractory model. Now, I'm going to do it two ways. One is I would just block everything out as such. And we'll take all the wax below the height of contour off. But if I had drawn my red line appropriately, which I did, I'll do it on this side. I mean, that's just semantics to practice with your surveyor. But we know that we'll just create a ledge just below the red line here with my blockout wax. And the stronger the ledge, then the more it's visible. And this is just as a waxing guide. Do not go into the guide surface with the ledge. We know there's no undercut. Although we can put a little bit on the gingival margin. If we chose not to put any of the gingival margin, we'll just be grinding the chrome. A little bit at the gingival margin, freehand. And then you can see my ledge on the 4-4. I'll try to make it a little bolder. And there we have a ledge for the retentive arm. Now, because this is an apron on the back, the only block out that we would do is gingival margin or below the height of contour of any teeth. And the only teeth that have any type of contour are on the lingual side are these bicuspids. So I'm going to use my surveyor and block out the wax right below the height of contour. Now, theoretically, there should be wax just below that pencil line, because that pencil line demarcated the height of contour. One thing that would have helped us if I had my major connector extensions above the height of contour, above the cingulum of the anterior teeth. I had it for my base plate here. Above the height of contour. If we're below the height of contour, we'll have a space of our apron, and that's kind of poor. Straight down, if I show you from this angle, straight down, maybe curving a little bit to the distal. Straight down, maybe curving from the distal, from the proximal surface of the distal of the bicuspids. And then not all the way down the major connector to the sulcus, because we might have some overextension there. around the frenum. And this would all be in blue because these are passive parts. And then slightly above the extension of the, maybe about halfway, we'll put the mesh lattice retention. About halfway. Meaning halfway from the lingual gingiva margin to the, because we want room for acrylic. This is just acrylic retention. It could be a little bit lower there, Paul. This is acrylic retention. Actually, I didn't even need to keep it on the surveyor for all those procedures, but we're going to bring in our blockout wax, our 0.6 blockout wax for our posterior teeth. Surgerize roughly how much I need. Keep this nice and sharp for the internal finishing line. Maybe I'll zoom in and try to get it on the screen here. And I'm blocking out all the way from the lingual sulcus to the buccal sulcus. I'm going to surgerize this nice and sharp internal finishing line. We're going to talk about shoe extensions on another project. But for now, we're still, getting our feet wet in the framework design. And then we need some on the other side as well. And this will be our spacer for our mesh retention. The mesh retention is waxed up on top of this spacer, maybe not obviously as lingual and labial or labial and buccal as this. And then hanging off the end where I put these little blue squares is our tissue stops, which will touch on the tissue and support our framework during the fitting stage and our try-in stage of the partial and processing indicators as well. Nothing is moved, lift, or shifted. Do not put any extra wax in the guide plane with this. A bit of a, let's say, beginner type of guide plane we're going to talk about is we'll seal this up here at the gingival margin. And then we're going to seal down here at the bottom. So no silicone and or hydrocolloid will lift underneath our pattern or our spacer, excuse me. So we optimized the path of insertion. We tripoded the model in two ways. We measured the depth of the undercut for the G-clasp in its retentive arm at 0.25 millimeters. We've ledged the G-clasp buccal arm, and we've blocked out any undesirable undercuts like around the gingival margin and or any undercuts on the lingual of the 3-4 and 4-4. There's a rest in here and a rest in here, obviously. This is our fulcrum line. So there we have our blockout. We're going to use a hydrocolloid duplication material now. So we're going to soak the model substantially for 15 minutes. And then we're going to go and proceed into the hydrocolloid flasks, which I'll demonstrate. So a bit brief, but a recap for class 1. The design. Mesocclusal rest, for this reason, as not to pull our abutment tooth into the free end once there's a load applied on this free end. Because the tissue has a give to it. There is a submucosa and mucosa, depending on how mobile the tissue is, even more rotation around this fulcrum line, which is an imaginary line drawn through the two most distal rests. Bisected medially anterior to that is an indirect retention, preventing the lift, or a hand, so to speak, preventing a lift of the free end. Preventing the load, stress-breaking clasps on the 3-4 and 4-4. Not too deep into the undercut, as if the load is very heavily applied, these clasps will engage as to take the pressure, stress breaking off 3-4 and 4-4, not to elongate those periodontal ligaments anymore. Our acceptable clasp design for class 1, RPI, RPG, RPY. We know what the last letter acronym for is, the clasp. The P is the proximal plate. And the proximal plate is this guide surface here on the distal of 3, 4, and 4, 4. And the R stands for rest, which is located at the mesial. We'll be going over this again, but I hope that helps you out with project number 2, and we'll catch up.